Hey guys, hope you're having a good Labor Day weekend. But we are going to talk about correlation, and then we'll have some activities in class to deal with that. So let's go ahead and get started. When we talk about correlation, we're looking at it's a measure of the relationship between two variables. And so you look at the word correlation, and it has the word relation in it, right? So obviously we're looking for the relationship in a relationship dealing with two variables or two people, right? The word co in there also shows the dependency. So two variables that have a relationship. And so in this we have a couple of different types of correlations that we're going to look at. One is a positive correlation. And so in a positive correlation, two variables are going to increase together. And so they're both going to go up at the same time. All right, so they're going to increase at the same time. And so, for example, the number of gallons of gas pumped is positively correlated to the amount of money spent on gas. Right. So for every gallon that you pump, you're going to increase the amount of money that you're going to spend on that gas. And so it also works in the other direction. The fewer amounts of gas gallons that you pump of gas, the less money you're going to spend. All right, so they're going to move in the same direction, so they can move up or down in the same direction. Now, negative correlation, the variables are going to be moving in opposite directions. All right, so as one increases, right, then the other will decrease. Right. So when we look at this, we look at a negative correlation example is the miles traveled is negatively correlated to the amount of gas left in your tank. So the more miles that you travel, the less gas you're going to take because you're going to use that gas, obviously, to get where you need to go. And so obviously with the less amount of gas or less amount of miles you travel, the less gas you're going to use, right? So positive correlations, they move the relationship, the two variables will move in the same direction, either up or down. And the negative correlation, they're going to move in opposite directions. Now, there's also strong and weak correlations, and we'll look at more at this with the correlation coefficient here in a little bit. But strong correlation is where variables are very related. So when we look at the example of height and weight, right? The taller you are, the more weight, the more you're going to weigh. So obviously that one is going to be, those two variables will be very related. So it'll be a strong correlation. A weak correlation would be where the variables are not very related, or not related at all. So when we look at hair color related to fun, right? The old myth that blondes have more fun. So the lighter your hair color, the more fun you have, is not a very strong correlation, be a weak correlation. And then we'll look at what the way statistics bear that out here in a minute. All right, and so the way that we're able to see these things and where they're related is these visual graphs called scatter plots. And you've seen these in math class before, but a scatter plot is just a graph of with clusters of dots, and they each represent the value of the two variables. So the slope of points depicted in the direction of the relationship depicts the direction of the relationship, positive, negative, or no relationship at all. And the amount of scatter suggests the strength of the correlation, right? So here you can see, right, the greenish teal line here is the line of what they call the line of best fit. And so it shows a positive correlation here where you have your numbers here, your values on the y and x axis. So as they increase in this direction, the numbers are also increasing in this direction, showing a positive correlation. All right, so here on the y axis and x axis, it's going to be doing the opposite. So as numbers are going up, here on the y axis, right, the values are going down here on the x axis. All right, and then here, there's really no relationship at all. It does not show, really, it shows a lot of variability there. So there's no relationship or no correlation shown in that scatter plot. All right, and so statistically, the way we bear out the correlation is with or determine the relationship, the strength of the relationship is with the correlation coefficient. And it's a statistical measure that's going to show the degree of relationship between the two variables. And the correlation coefficient is represented in the equation as R. And so here you can see it'll show either a plus or a minus, and here you see a plus, and so, or positive, and it shows the direction of the relationship. So positive means that the line of best fit is going to be like we showed there. It's going to be kind of gradually increasing, going up. And then in the other direction on negative, it's going to be going down. And then obviously the number after the decimal is going to indicate the strength of the relationship. So the closer that it is to 1, the stronger the relationship, and the closer to 0, the less there is a relationship. So the number will always fall between -1 and +1. The higher the number, the stronger the relationship. The closer to 1, the stronger the relationship. All right, so when you're looking at correlation coefficient examples, we talk about the closer to 1, and you'll see this bear out here in a second, right? So what kind of correlation do you have, right? The negative sign shows that we have a negative correlation, and 0.78, right, is only 22, about 22 points away from 1. So it's going to be a moderately strong negative correlation there. We look at plus 0.05. Obviously, it's closer to 0, so it's going to be a very weak positive correlation, right? The positive coming from the plus sign in front. And so here we know we're dealing with a negative. It's 0.43. It's going to be right almost to 50% there. So we're looking at a moderately weak negative correlation. And then the last one, we look at plus 0.92 is a very positive correlation there. All right, another example, scatter plot showing the relationship between height and temperament in people. What kind of relationship is depicted here? All right, and so you can see kind of where it lays out here. This is going to be your, and I'll put it on there for you, your line of best fit is going to go somewhere in here, right along these points. All right. And so what this will bear out is that it's going to be a positive correlation between your height in inches and your temperament score. So as your height increases, your temperament score is also going to increase. And so the correlation coefficient is going to be a positive 0.6 there, roughly. All right, so when we look at correlation and correlational research, the main thing, and when we're looking at research, is we're looking at what things cause other things to happen, and can a correlation study tell us if one thing is causing another? And so when we look at this, low self-esteem, it could cause depression, or depression could cause low self-esteem. So depressing events or biological predispositions could cause both low self-esteem and depression. So knowing that two items are correlated does not necessarily tell us why or exactly how they're related. So we do know that we know there's a relationship, but we don't know, based on the correlational research and the findings that we have, what causes them to be related. Does one cause the other? Does the other cause one? And then is there some other variable that we're not aware of that causes both of those things to occur at the same time, or one after another? All right, so because of this, and one thing that you know, and I have it up on my bulletin board in the classroom, you'll see it, is that correlation does not prove causation. Right, so correlation, a relationship, does not show that one of these conditions or one of these things in the relationship causes the other, and vice versa. All right, and then finally, the last part, the illusory correlation, one of your vocab terms. An illusory correlation is the perception of a relationship where none exists, and it's influenced by our confirmation bias. And it's where we look for information to confirm our belief and ignore evidence to the contrary. So we're only looking to affirm what we already know. We don't pay attention to evidence to the contrary. So example, a football fan believes that every time he wears a specific jersey that his team wins, and so each time they play, he'll only wear that jersey. And you see this a lot, especially in baseball, and other sports. But athletes are creatures of habit, so they will wear the same socks, or they will wear the same uniform, they'll eat the same meal, thinking that it's going to have some impact. And while you may have a relationship between those two things happening, there is no evidence to support that if you eat fried chicken that you're going to get a game-winning hit in that game, or go 3 for 4, or make 9 3-pointers in a game. So it is an illusory correlation, or perceiving a relationship where it does not exist. All right, I hope you have a good rest of the weekend, and we'll do some activities on correlation in class on Tuesday and begin experimentation. Have a great weekend.